Welcome to Machine Learning in Motion, Privacy, Robustness, and Real-World Impact. In this episode, we explore 42 new research papers from the Computer Science Machine Learning category, published on June 27, 2025. We'll spotlight innovations in privacy, robustness, efficiency, and practical applications of artificial intelligence. Our feature paper is CLoVE by Randeep, Bhatia, and collaborators. Join AI Frontiers as your guide to the breakthroughs shaping tomorrow's AI. Imagine a world where your health app detects illness early while keeping your personal data private. Picture drones that adapt in real time, even if their sensors are hacked mid-flight. Across devices, sensors, and applications, machine learning models are learning and improving without ever exposing your secrets. This is not science fiction. It's the forefront of today's research. The question is, what unfolds when artificial intelligence meets the real world? Why does this research matter now? Machine learning is the engine powering daily life, from healthcare and transportation to personal safety. The cs.LG, or Computer Science Machine Learning section, represents a thriving center of innovation. With 42 fresh papers, the field's creativity and energy are on full display. Our purpose today is to unpack these advances, understand their impact, and invite you to explore, question, and help shape the future of artificial intelligence. Let's look at machine learning as a living, evolving garden. Here, algorithms act as gardeners. Learning patterns from data, photos, text, and sensor readings serve as the fertile soil. Just as gardeners adapt their methods for different plants and changing weather, machine learning models evolve, facing new challenges and incorporating ideas from statistics, optimization, and even physics. The cs.LG ecosystem is vibrant and innovative, blooming with new approaches every day. The first major research theme is federated and decentralized learning. In federated learning, models are trained directly on devices, ensuring that raw data never leaves its source. This is like multiple chefs sharing baking tips without revealing their family recipes. Randeep, Bhatia and colleagues present CLoVE, clustering devices based on model performance. Abdulmumin Gulka and team introduce sheaf-based decentralized learning. At the core, these innovations enable privacy and personalization without central data aggregation. Robustness and adaptation form the second research theme. Models must endure sensor failures, cyber attacks, and shifting data landscapes. Much like self-driving cars handling unpredictable weather or malfunctioning sensors, Pritam and collaborators introduce Armor, a framework that keeps drones operational even during GPS spoofing attacks. Yongkyun Oh's work explores domain adaptation in medical time series, transferring knowledge across hospitals with differing data. Robustness is essential for reliability beyond controlled environments. The third theme centers on efficient exploration and interpretability. Rapid learning is vital when mistakes are costly, as in robotics or medicine. Tom Yang and colleagues propose value-incentivized actor-critic methods for reinforcement learning. Maciej Stefaniak's work focuses on compressing transformer models for efficiency. Erkan Turan and team employed a Koopman operator, enabling generative models that are both faster and more interpretable. The key principle here is efficient learning and transparent decision-making. Let's bring these themes to life through key findings. The CLoVE algorithm by Randeep, Bhatia et al. Clusters devices to deliver tailored models, balancing privacy with performance. The Armor framework from Pritam et al. Ensures drones remain resilient even under attack. Erkan Turan's Koopman augmented models demonstrate rapid, interpretable sample generation. Each breakthrough addresses a critical real-world need, be it privacy, robustness, or efficiency, proving that these are more than algorithms. They are solutions to tangible human challenges. Highlighting our paper of the day, CLoVE, by Randeep, Bhatia, and team tackles a nuanced challenge: how to group devices with similar data, all while preserving privacy. CLoVE utilizes loss vectors, unique fingerprints summarizing how well a model fits local data. The algorithm clusters devices based on these patterns, then trains specialized models for each group. Importantly, it does not require advanced knowledge of group counts or device labels, offering both theoretical guarantees and rapid runtime. How does CLoVE operate at its technical core? Each device computes a loss vector, encapsulating its model's performance on local data. Rather than sharing raw data, only these vectors are communicated, revealing relationships between devices while maintaining privacy. The algorithm clusters devices with similar loss patterns and then trains group-specific models that adapt as devices and data evolve. In empirical tests, CLoVE outperforms baseline methods in both accuracy and computational speed. CLoVE's impact is substantial for real-world artificial intelligence. It enables privacy-preserving personalization, an essential requirement in healthcare, finance, and the Internet of Things. By handling data heterogeneity, such as the differences between rural clinics, urban hospitals, or wearable devices, CLoVE reliably identifies true clusters even in diverse environments. Its design is simple enough for practical systems, yet robust enough to bridge the gap between privacy and high performance in today's complex data landscape. Looking ahead, the future of machine learning is defined by smarter, safer systems. Federated learning combines with robust representation techniques to enhance privacy and resilience. Symbolic reasoning and deep learning are merging to impart common sense to AI. Quantum classical hybrid models promise significant advances in speed and analytical power. Picture a city quietly energized by invisible, trustworthy AI helpers. The next frontier involves addressing fairness, reducing energy consumption, and improving generalization across varied tasks. In conclusion, today's 42 papers, featuring research by Bhatia, Turan, and others, advance privacy, resilience, and real-world applicability in artificial intelligence. These innovations are steadily building trust, safety, and efficiency into the systems we rely on. The benefits are already visible in our phones, drones, and hospitals. Listeners are encouraged to explore, share, and question, as the future of AI is shaped by each new question and breakthrough. This presentation was synthesized using advanced AI tools. Paper summaries were generated with OpenAI GPT 4.1, while TTS audio was produced via Deepgram. Visuals were created using OpenAI's image models. Human experts curated and reviewed the narrative for both technical and factual accuracy. All referenced works are transparently included. While every effort has been made to ensure accuracy, some oversights may occur. Community feedback is always appreciated. Subscribe to AI Frontiers for weekly deep dives into the world of machine learning and artificial intelligence. Join our community to ask questions, share insights, and suggest future topics. Find us under AI Frontiers and explore more with interviews, detailed paper breakdowns, and live Q&A sessions. Your journey into machine learning innovation starts here. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive preprint server content under its AI terms of use. AI Frontiers is not affiliated with or endorsed by archive preprint server.